Alright, today we're looking at solving problems that involve a sketching of parabolas. So it's like it says on the box, that's what we're going to be able to do. We're going to be able to solve these problems, and we might need to sketch a parabola in the process. So in a problem, you might be asked for the largest value, the smallest value, the maximum, the minimum value. Alright, for that we can find the turning point for a parabola, and we should be pretty sweet because that usually gives us the maximum or minimum value. We want to make sure we sketch our parabola though, sketch the relationship to see kind of how the relationship kind of forms. So we can find this by finding the turning point for a relevant parabola. So just like solving any problem that involves, some kind of algebraic relationship, we need to make sure we define the variable before writing the equation. Decide on a range to do the plotting, sketch the parabola by finding the intercepts and the turning point, and then find that maximum or minimum value. Have a look visually. Now, although it might not be necessary for you specifically to sketch the graph to find the turning point, you might be able to do it all in your head and have a look. It is going to be helpful there to have a graph to make sure that A, you're correct, that it makes sense that we're finding a maximum value and not a minimum value. You haven't done something wrong with your calculations and things like that. As well, it helps the reader to understand your solution to the problem, which is key and paramount in communication. So let's have a look at doing an example that shows all of these steps and shows everything you need to do to solve the problem. Here it is. We've got a piece of wire. It measures 100 centimeters. In length, it's 100 centimeters from end to end. We're going to bend it. We're going to bend it into a shape of a rectangle. We need to determine the maximum area of it. Determine the maximum area of that rectangle. Determine the dimensions of the rectangle. So, firstly, define those variables. We're going to say W is the width and L is the length. And we're going to say A is the area of the rectangle. Okay, the length, the width, the area of the rectangle. Firstly, we need to somehow incorporate this 100 centimeters. So if we're looking, our 100 centimeters is going to be all around the length of our rectangle. It's going to be the perimeter. Perimeter of our rectangle, P, is equal to 2 times the length plus the width, because we've got, we've got 2 lengths, we've got 2 widths, and they're the same. That's it, and we've got to go all the way around the edge. So that's going to be 100. This is 2 times length plus the width. So that means 50, if I divide both sides by 2, it's going to be length plus the width. So that means the length is going to be equal to the width minus 50. All right, it's going to be a difference of 50 in between them. No, there's not. They're going to add to 50. They're going to add to 50. So we know the length is equal to the width minus 50. The area of a rectangle as well, we know, is length times width. Length times width. Substitute in, this is what we're trying to find. This is why we're doing this whole thing, because we're asked the maximum area of the rectangle. How big an area can we get? Length times width. Well, the length we know is W minus 50 multiplied by W. Now, we can leave it like this. We can leave it like this, but it's not super easy to solve in some instances. We might want to revert back to this form later on. I'll show you why it's, but we just need to remember that it's equivalent, right? But we can expand it out. We can expand it out and get W squared minus 50W. Got a feeling I've done something wrong, and it's back here. You all didn't pick me up on it. Here it is. That's wrong. It's not length times W minus 50. It's length is equal to 50 minus W. See? If I take W from both sides, come on, it's 50 minus W. Gosh, I'm doing something wrong here. So this is 50 minus W, and this here, this is not that. This is equal to 50W minus W squared. Okay, 50W minus W squared. So if I was graphing this, I put in the width, and I want to get what area that's going to give me. So, the area is going to be on the y-axis. and w is going to be on our x-axis. So we get 50x minus x squared. It's not really in the format of y equals ax squared plus bx plus c though. So let's just make it, just for simplicity's sake, it's not really simple. Negative x squared plus 50x. At least it's in the form of ax squared plus bx. So we've got our equation now. Hey, that's pretty good. That's pretty good. We're on our way. So this is what we're trying to do. We're gonna graph this. And so remember, when we're graphing a parabola, we've got to find y-intercept, x-intercept, turning point. So we've got to find. So let's do that. Let's do those things. So we got here, the equation that we had was y equals negative x squared plus 50x. Okay? So y equals negative x squared plus 50x. All right. Let's find the y-intercept here. Remember y-intercept, did I do a little underline here? That's when x equals 0. And if we substitute in, we get y equals negative 0 squared plus 50 times 0. It's just 0. So that means, therefore, y-intercept occurs at 0, 0. That's pretty convenient. That's pretty easy. All right, let's look at x-intercept here. That's when y equals 0. A little bit trickier now. All right, so we get 0 equals negative x squared plus 50x. This is where we go back to our original factorized form, because it turns out it's actually a little bit easier. Because, I mean, you can do your whatever, but you know, you can factorize. You might need to factorize. You might need to do that sort of thing. But it's in factorized form. You're halfway there. You've already got your x-intercepts. It's a lot easier. It's a lot easier to find, because then you can use the null factor law. So we've got our common factor of x, and we get negative x plus 50. So that means either of these things must be 0. So either x equals 0 or x equals negative x plus 50. No. Negative x plus 50 equals 0. Whew. So then we get negative x equals negative 50. We get x equals 50. So therefore, our x-intercepts x equals 0. No, not x equals 0. 0, 0. 0, 0 and 50, 0. Phew! All right. Hey, we're almost there. We got this one. We got these 2 points. We've got 3 points already. Well, no, this is the same point. Not 3 points, just 2. So we've got 2 points. Last point we need is the turning point. Turning point for this whole problem. Okay, and then we can put this whole thing behind us. Is that we get the turning point. Writing in red. That's not good. Turning point. Underline. Nice and neat. We get the x-coordinate. Remember, the x-coordinate is halfway in between the two x-intercepts. So that's 0 plus 50 over 2, which is 25. That's the x-coordinate. Substitute the y-coordinate in. Substitute the x-coordinate into the equation. So the equation that we got was negative 25 squared plus 50 times 25. So our x value is 25 from above here. And we get 625. Okay, so that's our turning point. Now we've got 3 points. We can graph those 3 points. Let's have a look. So I'm going to consider my axes here. Think about them. Consider them very carefully. And see where they're probably going to go to. We know that this is a point here, 0, 0, that we need to plot. 0, 0. This is a point on our graph. That was our y-intercept and also one of our x-intercepts. Another x-intercept that we have here is 50, 0. Another point there. We also had our axis of symmetry going through 25. So our maximum here is our turning point. So because the turning point, which I should have probably stated down here, neglected to. 25, turning point is 25, 625. 25, 625. So that means our maximum value here, up here, is going to be 625. And this is, remember, this is our area. This is what we've graphed on the y-axis, and on our x-axis, we've graphed the width. So it's very important. If your axes are not x and y, you've got to label them. You've got to label them. You've got to tell people what's going on, what the business is, what the story is. So now we have 3 points. We've got to join these 3 points with a parabola. Nice and smooth curve there. Okay, nice and smooth curve. And we can see that we get a maximum. We can see that we get a maximum. And this is our equation that we've got here. Our equation that we've got is A is equal to negative W squared plus 50 W. All right. So our maximum point is this turning point here. That's what we're asked for. We're asked for determine the maximum area of the rectangle. Okay, so we can state, therefore, the maximum area is 625 square centimeters. It also asks for the dimensions of the rectangle. Okay, it asks for the dimensions of the rectangle. So we know the width is 25 centimeters. W equals 25. Length equals 50 minus width. 50 minus 25. The length is also 25. We can finish off our statement because we've made a statement about the maximum area. We can say, therefore, the dimensions of our rectangle are 25 centimeters by 25 centimeters. The length is 25, the width is 25. We've got a square. We've got a square, and you can think that makes sense. It's going to make the maximum area, because if I've got a long and thin rectangle, it's going to have a zero area. It's going to have a very small area. Okay, it's going to be really long and thin. If I've got a really tall rectangle, it's going to be long and thin. In between those two, the wide and low, and the tall and thin is a square. That's, you know, if you've got the same amount of stuff, okay, you get a square. Okay, and that's going to be the maximum area there. So it makes sense. So let's recap what we need to do to answer these questions. Oh my gosh. So we need to define variables. We need to write an equation that we can then graph. Okay, then we sketch that parabola. We sketch that parabola using, by finding the y-intercept, the x-intercepts, the turning point. We sketch it to make sure we're communicating clearly. Then we answer the question. Okay, so we answer the question, we state what that maximum minimum is, or whatever we're trying to find, state dimensions, state, you know, the values that we get, you know, whatever we're asked to find. We do that in a sentence. Okay, we do it in a sentence at the end. Okay, thanks very much for listening.